Hello everyone, welcome back to today's NumPy array sorting algorithms in Python. In this tutorial, you will learn how to implement various sorting techniques using Python and NumPy to optimize your data analytics skills. To sort a NumPy array, you can use the numpy.sort function or sort method of the array itself. NumPy offers various sorting algorithms, including quicksort, mergesort, and heapsort. Here is a basic example of how to sort a NumPy array. First, create a NumPy array. This is a single dimensional array, and then using the numpy.sort function to create a sorted copy of the array. So sorted array, we can use numpy.sort. We pass array to the sort function, and we're gonna print out the sorted array. Okay. So here, the original array is this one. It is not in sorted array, but when I sorted this original array using sort function, the array is in ascending order, starting from the lowest to the highest values of the array. Okay, and using the sort method to sort the array in place, you can also in place, but in this case, the original array is not modified yet. You can print the original array to check that the array is modified or not. Yeah, the original array in this case is not modified yet because I just create a sorted copy of the original array using this way. But if you wanna just modify the original array or create the sorted array in place of the original array, you can use array.sort or the array name object name.sort. So it just sort the array in place of the original array, and when you are printing out the array, it's gonna sort in ascending order. Yeah. So the two are different ways. The first one is just creating a copy of the original array, is sorted array elements, but the second one is not creates a copy of the sorted array, but instead just sort the array in place of the original array. Okay. And the other thing is that you can learn about increasing or decreasing sort. In normal Python, there is a reverse parameter that sorts the elements, the sorted elements in increasing or decreasing order. But here, that parameter is not working in NumPy array. So you can use different techniques to sort the array. By default, it's in increasing order. But if you want to just sort the array in decreasing sort or decreasing order, you can use sort. So you can use -np dot sort, and you can apply minus in front of the array object name inside this sort function. So when you are printing this, so you can see that the array is in reverse order or in decreasing order. Okay, this is one of the way how you can sort the array, NumPy array in decreasing order. But by default, it is in increasing order. Yeah, so you don't need to apply any techniques to sort the array elements in increasing order. And the second alternative way of sorting the array in decreasing order is you can use slicing, negative slicing, and p.sort array. Outside, you can apply negative slicing, and you can print that decreasing sorted. And the second way to sort array elements is in decreasing order. So you can use either the first way or the second way to sort arrays in decreasing order. Okay, let's go on. You can also sort, but we have seen about sorting arrays in single dimensional array, but you can also sort a multi-dimensional array along a specific axes by specifying axis parameter. Here is an example. First, define or create a two-dimensional NumPy array. You can use like this, and then you can sort along the rows by specifying axis parameter to 0. Sorting along the rows, which is the axis parameter to 0. And you can see that, so create a copy of the 2D rows and p.sort and array 2D. Then you can pass axis parameter to 0 to sort along the rows, and you can see that sorted array 2D rows. Yeah, because this is rows, and you can specify that axis is 0. So here 1, 2, 3, 1, 5, 6, 4, 5, 6, 4, 5, 9. I mean 9. So this is the rows axis. And the other is you can also sort along the columns, sorting along the columns with axis 1. So you can sort each rows in the columns axis. NumPy does sort array 2D, and you can pass the axis parameter to 1. Then you can compare the result with the previous one. Of course. Yeah, here just sort each rows individually, then put like this. The previous one is when you are using along the rows, you can sort each columns instead of rows. So this is the two-dimensional array, so you can just use either rows or columns to sort your two-dimensional array elements. Okay. NumPy sorting functions are highly optimized and efficient for handling large arrays. You can also choose different sorting algorithms using the kind parameter, and which includes options like quicksort, mergesort, or heapsort. You can also use the order parameter to specify the field to use when sorting structure. Here is the quicksort. The quicksort algorithm. You can create an array, and you can pass the using sorting with quicksort algorithm. Sorted array quicksort, and you can pass an quicksort array, and you can pass kind parameter quicksort. This is the quicksort algorithm, and you can see that the sorted array with quicksort. Yeah, this is the quicksort, just in ascending order. And the second one is you can just uh, copy paste this one, and sorting with merge sorts. You can pass the kind parameter to merge sort. Yeah, this is the result is the same, but there are some differences in the sorting algorithm techniques. Here is heap sort. You can change this heap sort. And you can see that all are in ascending order. They are sorting the algorithm, but by default, NumPy sort function uses quicksort. Without using kind parameter in the quicksort, the NumPy uses the quicksort by default. But when you are passing the kind parameter to merge sort or heap sort, they have some differences. However, you can choose different algorithm based on your requirements. For example, the merge sort is a stable algorithm and is generally preferred when stability is required. So when do you use the merge sort? So this is one of the stable algorithm, and it is generally referred with stability is required. When you are required to stability, so you can use merge sort. And the heap sort has a guaranteed worst case performance. So, and it's useful for sorting in the presence of memory constraints. So, it's depending to choose the appropriate sorting algorithm based on various factors, including the size of the data, the desired stability of the sort. For example, if you want a desired stability, so you can use merge sort, and the memory constraints, especially the performance. So you can use heap sort. Otherwise, you can use quick sort, especially if the size of the data, if you have large array data, you can use quick sort. So I hope you have get some insight at how to implement the sorting algorithms using NumPy. Don't forget to like, share, and subscribe. Thanks for watching.